Welcome to our seminar, to our Tuesday seminars. Today we are fortunate to have Sergei Nirenburg. Sergei Nirenburg, well, I don't know, comes from Russia, Soviet Union actually, but was at Carnegie University, and then headed a language processing group at New Mexico State in Las Cruces. Is that how it's pronounced? Cruces?
Yes.
All right. And now he's with us in Baltimore, in University of Maryland, Baltimore County. And he's a famous person in machine translation and natural language processing. And he's going to talk to us on ontological semantics and overview.
Yeah. This is a knowledge-based linguistic theory and the knowledge-based NLP method of extracting, representing, and manipulating meaning in natural language text.
Why does it give you only a part?
It's just his laptop.
Oh, I have no idea.
Maybe you need to change the screen.
I already did.
Just the laptop.
Just move the projector to the right.
No. Okay, somebody.
Windows?
Nobody. No, this is not good. It actually, I would like it to see. What?
Okay.
I'll bring a different projector in 1 second.
All right. In that case, what I can do is I can tell you a little bit about the history of it first.
You can tell us the joke.
This is the joke. I'll wait a little bit. No, that's as always. I mean, if we get into that mode, yeah, we will. Right. So I started work in this direction kind of many years ago from the idea of trying to do machine translation of natural languages. And what appealed to me was the possibility, even if it's remote, and even today it's not completely something to be taken for granted, of being able to use meaning as the basis of translation. In other words, to go for what's known as an interlingual machine translation system, and this word is heavily laden with added meanings, but the big idea that kind of drove me to this type of research, and already for quite a long time, is trying to extract and represent a meaning in natural language. By the way, this immediately classes me as a mentalist. That is, I'm somebody who operates in concepts that are not visible to the unaided, naked eye, so to say. So we invent things and then we manipulate those inventions. Not an unusual type of approach in, well, let's say computational linguistics or artificial intelligence, but still, these days I need to make the apology because the behaviorism is rampant again in our field, as it should be. So we will wait till another swing of the pendulum the opposite way sometime later. So in fact, in linguistics and in computational linguistics, it is not unusual in the first lecture on the subject to say that, well, this is the science that deals with relations between sounds or the graphical variants of those sounds on the one hand. No.
I'm missing, I'm afraid. So.
Well, all right.
And is it really the fault of the projector?
No. It's a combination. It's an incompatibility.
So, can somebody help me while I'm talking, or shall I stop for a minute?
Just stop for a minute and
Yeah.
adjust to this place.
Yeah, well, I can do it this way,
Yeah.
not in this mode. If you can read.
Screen resolution, I think. Try right.
I already did
Oh, you
it
did
once.
this. Oh, yeah.
So,
Just do it this way. Yeah.
well, I can lower it again. What?
Those in the back should come in front if you can.
That is the good enticement. Yeah. Well, anyway, what I wanted to say, just to finish that thought, is that usually this statement about meaning remains on the first page of a textbook, and people do not usually go too far in talking about what it is and how to manipulate it and so on and so forth. And well, we tried our best in a certain approach, and I will not, unless asked about it, talk more about the turf divisions, how the different are similar to many other approaches and groups. So let's give you an overview of what we have been doing and what we've been trying to stress as types of issues. And what I would want to say also is that it would be nice if at some time in the future we could maybe come back and talk at a more technical level about particular angles and corners and tasks inside the paradigm that I'm discussing. So ontological semantic analyzers take natural language text as inputs and generate machine tractable text meaning representations, or TMRs, that form the basis for various reasoning processes. So these are expressions in a formal language that have that has its own semantics that is supposed to reflect the realm of meanings that can be represented in natural language. Okay, and the generators in principle take TMRs as inputs and produce natural language texts. Oh, now I have to do it differently. Okay, so one of the major things that we have to do in ontological semantics is build up static knowledge resources. And the main ones among them are a language-independent ontology, we call it. Well, we talked with Fred about the genesis of this new or semantic shift of the originally known word and concept of ontology as the science of being, and the, well, not quite frivolous, but still different use that we have started to put it to. I would blame Doug Leonard for it. Well, but why not? I mean, but I must say that I have been guilty of using this word of formal artificial ontology for quite some time myself. So it is a model of the world that includes models of intelligent agents, and we can talk about that and the presuppositions and assumptions that we made in building ours separately. Okay, another important part of the knowledge resources is the ontology-oriented lexicon. So we have, on the one hand, words and phrases in natural language, and with some serious simplification, some part of the content of the lexicon entries are pointers to ontological concepts, single or groups, modified or univocal, but still pointers to ontological concepts. And then also we are building what's known as fact repositories, where roughly speaking, well, it would be the following. If we suppose we analyze a certain text into a TMR, and then some components of those TMRs that we want to retain for future use, we will store in something called a fact repository. And those will be instances of ontological events and objects, interconnected and cross-indexed. So if, let's say, the concept of the President of the United States is an ontological concept, John Kennedy is a fact. So, clearly. There are cases in which this is not as clear as this division, but, well, if there are questions, we can go over how we distinguish that. Once again, I need to.
So this DMR is going to have pieces which you can pull out and put in your repository.
Yes, that's correct. That's correct. And by the way, when you need to, well, okay, in an application, for instance, we are working on some question answering applications right now. So the difference that we have from other people who are doing this, we are trying to do it in two steps. One of them is to take the texts off of which we in principle would be answering questions and transform them into a fact repository or a subset of a fact repository by producing the TMRs and then extracting, well, essentially templates from it, but semantically. Do that semantically, and then when the question comes around, you match not against something dynamically produced from text, but from this, and you see these are compatible formalisms and compatible, not only formalisms, also the content and the definition of the actual properties is the same, because it's all from the ontology.
So the ontology would have the concept of president related to the word president.
No, the ontology will have just the concept. The lexicon will have the meaning of
the ontology-oriented lexicon would have the concept of president.
It will have a pointer essentially to a concept with modifications of certain kind. For instance, there will be the word president, you see, and then there will be if the lexicon entry is for the word president, you see, it will not point to the President of the United States. It will point to a President of a nation, of which the President of the United States, if indeed this concept exists in the ontology, will be a child, a descendant. Right, and I will not talk about this today. There is a lot to be said about options of connecting between the meanings of the individual words and phrases and the ontological concepts. For instance, just to say one word about that, considering that we started all this entire operation with the idea of multilingual treatment, right? So the meanings will not be in the ontology, for instance, the elements of the ontology will not have one-to-one correspondences with actual meanings of all the words, meaningful words in the, no, let's say open class words in the lexicon of a particular language. There will be local modifications. The example that we used to use for a long time to explain it, for instance, is that the English verb to taxi is essentially to move on surface said of an airplane, right? So the idea would be that we don't want to introduce taxi as an ontological concept. Inside the lexicon entry, English lexicon entry for taxi, we will say move on surface, and we put in constraint right there, so that the ontology remains more language independent and generic. It's an art. It's not quite. There are no hard constraints here, but this is the general desire. Just so. Okay, let me continue. So these are the static knowledge sources, and there is a lot that can be said about each one and the communication. I will have just some examples of them in this talk. So applications are standard applications that all of us are trying to work on, even though we haven't been working on speech directly. Even though, let's say, Alex Weigel's group at CMU in Karlsruhe for a long time have been doing knowledge-based, that is, ontology-based analysis at the level when they got from the transcription to the meaning. So that's the approach that has been known to be used as the back end in the speech-to-speech translation, for instance. So translation, IR and IE, summarization, question answering, support for reasoning systems. For instance, right now we are subcontractors to a group at Stanford, the Richard Fikes group, who have this theorem prover about things in the world, and what they want to do is for us to help them produce actual space in which to apply the reasoning, because as with so many people who are dealing with the logic approaches to processing, there are always two parts of that. One of them is take the text, translate it into a logical form, and the second part is manipulate logical forms the way you need to. So most of the logicians, almost everybody with few notable exceptions, were doing the second part, but the first part was less, because it's empirically more difficult to do. So that's something that we are trying to help them with. So that's also supposedly a part of ontological semantics. Okay, the processing components also are predictable. We work with texts, we do various kinds of tokenization, morphological analysis, syntactic analysis, semantic analysis, lexical and compositional, pragmatics and discourse analysis. And the fact is that for us, it's not profitable for us to even separate pragmatics and discourse from semantics. It's all part of meaning to us, even though it's a different type of meaning. Well, knowledge-based reasoning, which in our case is done based also on static knowledge recorded in scripts. We will talk a little bit about that. And text generation, which is, well, it's just one line here, but there are a lot of issues in text generation that, as you know, that could be discussed further. Okay. This is, it was such a nice animation. But now, all right, but it's better for you because who needs animation after all? So this is the original simplified, very much simplified structure of ontological semantics applied to MT. So you have an input text of some kind, you put it through the analyzer, you get a text meaning representation that you submit to the generator, and you produce the output text. And in order to do that, you have to have lots of knowledge resources, the ecology and morphology and syntax knowledge about the language. And then the lexicon, the meaning part, meaning zones of which are formulated in terms of this meta-language defined by the ontology. What I'm saying right now is a simplification, because there are a set of important components of meaning that are not, formally speaking, ontological, but are rather parameterized out of the ontology and done in the set of special rules directly in the text meaning representation. One example of that is, for instance, the microtheory of aspect that we have, that aspectual, lexical, and syntactic forms get directly transformed into a certain image in the TMR, and they don't have necessarily an ontological reality outside of having a scope, which is a certain element of ontology. There is some event that has, let's say, a phase begin, right? But it's not a part of the ontology. So when I'm saying, you see, what I don't want to impart to you is the idea that the meaning is mechanistic. It's like word, ontological representation, word, ontological representation. It's not like that. It's more complex. Even though most of the open class items indeed follow that type of discipline. This is a more complex view of the same thing. So I'm sorry that this is so crowded, but what this thing adds is that there is a basic TMR that we first produced in the first application of the analyzer. And then, based on other knowledge in the TMR itself and in the background that is in the ontology, for instance, knowledge about scripts and so on, and also knowledge about the application, for instance, the types of questions that need to answer. We augment the TMR to produce an extended TMR. One thing that I want to mention is what's happening here is resolution of reference, as all of us are trying to do. And what we are trying to do here is not to go so much for co-reference at the level of locutions of the language as to co-reference at the level of instances of ontological concepts. So pointing to the same entity and not to the same word or something like that. Okay, so I already mentioned much of the elements. Okay, this is important to know. This is our approach to life. We believe that what we are descriptive computational linguists. In other words, this means that we are processing naturally occurring texts. We strive for broad coverage. Obviously, it's one of the most difficult issues for us in this type of approach. And we expect unexpected inputs. In other words, we know that at any time in the process, however much we have acquired, however much knowledge we have acquired, we still will hit something that we didn't expect. Right? And this is, well, with people, as far as I know, that are here, this is not such a big deal. This is to be expected, but there is a large group of people who don't care about those types of issues and call this, roughly speaking, performance. Okay, there have been a number of applications of ontological semantics over the years in various projects. Some of them are mentioned here: Microcosmos, a machine translation project; Savona, which is a planner, and Minds, which is an information extraction project. And Crest was a project where we did a bit of question answering. Mocha is a better, more advanced question answering project that we are running right now. But there are some others too that we have dealt with. It's simply by way of reference. Okay, so what we have right now, and it's difficult to count, but we have right now an ontology of about 6,000 concepts, about 85,000 quote facts, so property value pairs, right? And this ontology has allowed us to produce an English lexicon of about 45,000 entries, word senses, not lexemes, okay? We call those super entries and these entries, whatever, that's jargon. A Spanish lexicon of about the same size, a small Chinese lexicon, and also we have one fact repository which we built for one of those projects I mentioned, which was about the Sydney Olympic Games in 2000. So, we use that for question answering in the Crest project. Also, we have, in addition to this is knowledge resources that are devoted to ontological semantic processing to whatever depth we can do it. In addition to that, we have a lot of resources that do not get that deeply, but we have quite a lot of morphological and syntactic grammars and lexicons that do not yet have the semantic components, and onomasticons, the lexicons of names, for a variety of languages, maybe 15 different languages. And I say we, that is the fact about the Computing Research Lab at New Mexico State, where I used to work until last September. And this is actually available to people in the field, so I suppose, yeah.
Could you give me an example? I'm confused between the concept and the fact, because
the concept, once again, the concept will be, for instance, to travel, which is an event, a complex event, and an instance will be a visit by Powell to China.
But you said in your ontology you have 6,000 concepts and
right, the concept,
facts.
Yeah, the facts are simply, okay,
and then there's
fair
the
enough.
repository. So
Different facts, good. It's a loose use of terminology. Because when I say facts, what I should have said, correct. I should have said here, something different. I should have said something like property value pairs, because what it means essentially is that there are about 14 and a half on average properties defined per concept.
Okay,
and then I multiply, because you see, it's simply depends on how people measure this. Numbers are whatever numbers are, right? By the way, we keep working on all of these knowledge resources, and knowledge acquisition is one of the biggest drains on time and effort here.
But I don't understand this anyway. The example of Powell visiting China is overwhelming, right? I mean, there is also me going to New York and you going somewhere, and you can't have it all.
Yes, you can. Why? Why not?
everything that ever happened, you can
Oh,
have
no,
in
no,
the
no, no,
facts,
look, as
in
usual,
in the facts
Fred,
repository.
look, in principle you can. In practice, you process a certain set of texts, and it's from there that you get a certain subset. For instance, if we are dealing with, let's say, a domain in which we are covering issues like travel and meetings, right? Then we will expect to extract from whatever we analyze information about particular meetings, and this meeting or travel or whatever, there will be possibly a subset of properties from the ontological concept that we will say, okay, these we will somehow spider into from, well, it's not, the word spider is not right, convert from the TMR into the fact. And it will be indexed simply by number. And, we obviously can use better DBMS support for that, I'm sure. We don't right now. We still have it in flat files, essentially, which is not good. But that's a separate issue. And obviously, it will be finite. Moreover, there are many issues here, because you see, the truth maintenance is an important issue in such things. Also, the fact that if you get 5 or 6 or 7 different stories about the same event from different sources and also from the same source over time, you will have different pieces of knowledge there. And we have certain devices to attribute certain property values to certain sources and to certain time, right? And this is a complication because it's not purely ontological. It's simply indexing it. But at this time I cannot even answer real questions about problems with size. We don't have too many. You know, the 20,000 facts from the Olympics is not enough to worry us. You see, but maybe I wish we get to problems of that sort. All right, but the big idea right now for us is to try to produce that so that we can do question answering off of processed, machine tractable stuff and not unprocessed text. That's the thing. Okay, so you have seen this already while I was talking. This is the kind of schematic relations between among the ontology on this side, the lexicon, the nomasticon, and the fact repository, right? So there are object instances and event instances, ontological, in the fact repository. The lexicon goes into various components of ontology, and mind you, deliberately not every element in the lexicon has a connection with the ontology, but for the onomasticon, essentially, yes, we know the names, and these names very often go to elements that we know in the fact repository, but of course, in addition to that, we also know that certain strings mean typical names, and this is stored there too. So it doesn't relate directly to the fact repository. Okay, the processing components, preprocessors, syntactic analyzers. We have several optional ones that we use, and we have a semantic analyzer, but it's not monolithic. It's a number of different routines. I will mention briefly several of them right now, and there will be more that will remain. We have one text, no, actually we have more than one text generator. But the generation that we do is only into English, because of the nature of projects that we have been dealing with. And then we have also some work, have done some work in control architectures that might be also interesting. We have worked also on knowledge acquisition tools, and we have too many knowledge acquisition tools, which is another way of saying that none of them is wonderful. So we need possibly more and more of that. Right. Well, some of the collaborators are listed here over the years. People who spent significant amount of time working on these issues over the years. And as you can see already, this is a broad and shallow overview of what we've been doing. So another view of the analysis process. We have the preprocessor, the syntactic analyzer, and the semantic analyzer. And I will not give you detailed examples right now, but let's start with a toy example of a fragment of a text meaning representation, a TMR. It has a proposition here whose head is the instance of an ontological concept. The number is simply done here to stress that this is not a concept, but rather an instance. And it has properties. These properties are familiar case roles, but there are other properties possible that certain inputs will engender. And these properties are filled by instances of other ontological concepts that are meanings of other parts of the sentence. So this would be something like Mr. Smith arrived from London to Ankara on July the 2nd, 2000, right? And this is deliberately simple because there are obviously problems at every point here. One point to notice is that even this fragment of the semantic representation does not have everything in the standard semantic dependency way of writing, because we have the TMR time is parameterized. We have a very simplistic, deliberately simplistic treatment of time because it's too difficult to establish, to use advanced time logics. We can talk about this separately, why we do that. And this is the example of aspect that we get from the sentence. This is a single iteration of the event, and this event stresses the end of this. So the end of travel. It was arrive. The word arrive was there, right? Okay. So let's see how we do this dependency on another small example. And it's a you see, I have on this machine results of actual analyzer runs, but there it would be cruel for me to show you them because we don't have a very good viewer of this, and this is like it's difficult. You need to learn the structure. So this is much simplified, but the idea is to impart some kind of principle here. So we have John Make's tools, right, as an input, and the syntactic analysis is there is the root make, and the category of it is verb, the present tense, subject, root John, category noun proper, object, root tool, category noun, number plural. This is the standard, one of the many standard ways of representing the syntax of the input. Relevant parts of the lexical entry for make. So this is a glimpse into the lexicon. There is the syntactic structure zone, and there is the semantic structure zone. By the way, this is the formalism is homegrown, influenced by, you will understand, it's influenced by LFG on the syntactic side and certain more obscure influences on the semantic side. But what we want to know here is that make in its first verbal sense is the following. It says that it expects the subcategorization for a subject and object. They both
What was the word?
subcategorization.
Subcategorization.
Yeah, for a subject and an object that are constrained to nominals, and what we have for variables is our way simply of marking linking between the syntactic dependency and the semantic dependency, right? So what the semantic structure is this. It says go, when you see make in this sense, go and introduce into the TMR an instance of manufacturing activity, which is an ontological concept, and connect the age to the agent of manufacturing activity, whatever is the meaning of variable one. The caret reads meaning of. right? And to the theme, whatever is the meaning of variable 2. Okay, and this is really the vanilla lexicon entry in the lexicon. Now, remember, it just pointed to manufacturing activity. It means that it's a univocal mapping, that it's exactly the meaning. There are no constraints on the side, on the lexical side. But the relevant extract from ontological concept specification, you see this manufacturing activity, there will be constraints. The agent will be constrained to a human, and the theme will be constrained to the artifact. Simple, right? By the way, all of this is rather simplified. There is more information in the actual resources, and we will come to this in a little while. Okay, relevant parts of the lexicon entries for John and tool. Well, no surprises. Root is the synstruct is the simple noun, proper noun, and the semantic structure, it's a human. The property John goes under name, the property name, and the gender is male. By the way, you could say that this is not right here, but well, we suppose we write it and we get this property a certain confidence level. Okay, and then the tool is once again a very simple mapping into the ontological concept tool. You can ask me right now why it is that we are using English words and phrases to name ontological concepts too, because it's kind of confusing when you look at these examples, because this tool that's highlighted is an element of the ontology, whereas let's see, yeah, whereas this tool is the element of the English language, right? So, well, I think you understand why this was done, because it was the result of the reasoning of like thinking about the what is the best of the two not so good decisions, because you see the ontology and all these resources, unfortunately, well, just like programs, are used not only for running in a system, but also by people who read them. And if you use some kind of a gensim or whatever, it takes too much time to understand what the whole thing is about. And I understand that there is this claim about, quote, uppercase semantics. If you know what I refer to, people said that many other people say that the semantics of some lexical element would be that same word written in uppercase, which in this was a well-known criticism by Drew McDermott of AI at a certain stage. But here you see, since we do have properties and values which are defined in the ontologies themselves, you see, that is the meaning, and this is only a label. It's the label itself does not serve an important function. Okay, so let me quickly read this. What happens in this processing? The lexicon entry for make establishes that the meaning of the syntactic subject of make is the main candidate to fill the agent slot in manufacturing activity, right? And the direct object will be, or the object will be, the theme. And what we do there is also, in order to put together, to combine these meanings, to compose them, we need to check the selectional restrictions. That is, we need to see that John is a human and the tools are artifacts. Because if you remember, artifacts were expected on manufacturing activity, the themes of manufacturing activity, right? In this case, it so happens that indeed it is so. So the basic semantic dependency component of the TMR for John makes tools is as follows. It says certain instance of manufacturing activity. Agent is certain instance of a human. I do not list them here. And the theme is a certain set whose element is a tool and whose cardinality is greater than 1. That's all we know, and that's how plural in this case gets processed, okay? There are other issues here also that could be discussed, but we will not round up or round out rather the TMR here. It's just this component. Well, there are other processes, there are other combinations that we need to deal with that are not the main argument predicate type of situations, like John makes tools quickly, so we need to add quickly somehow as a property. John makes expensive tools, John makes very expensive tools, and John makes power tools. You see, all of this needs to be somehow connected, and there are very interesting points here. One of them is, well, the adjectives modify certain properties of nouns that they modify, only there are many adjectives that actually do not modify semantically the nouns that they modify syntactically. This is a very widespread situation, like the road went up for 6 relentless miles. Miles are not relentless. And so on and so forth. And by the way, even the meaning of the word good is not really a modification of whatever is good. It's a modification of what you feel about a certain, what your attitude is to that object. Because what's good for me is not good for you, and what's good for this table is not good for an elephant, and so on. So there are all those things. Now, what is the problem with vary? And these are just examples of issues that we have. Vary has a procedural meaning. And by the way, there are many elements in the language whose meanings are not really mappings, but procedural meanings. What vary does, it modifies the range of the value of the property that it modifies syntactically. So big, okay, if there is the whole range of possibilities of size, from let's say 0 to 1, abstract, because we don't know what the absolute numbers are, right? Big anything is from, let's say, 0.75 to 1, that side of it, right? Do you understand what I mean? Yeah, because you see, the absolute sizes, the ranges, are listed in the ontology. So when somebody says he was tall for a basketball player, it means something special. You see, because for basketball player, you will say, okay, typical height is between this and this, right? So what I'm saying is that vary makes it smaller, the range, right? It's from 85 to 1. So what I'm trying to, or whatever, the numbers are not so important. But the idea is that there are some words whose meanings actually trigger procedures. By the way, in the old days, there was even a whole approach to semantics that was called procedural semantics. People like Terry Winograd and Yorick Wilkes and Bill Woods were promulgating, like, about the early 80s, the latest. And they included this idea of meanings as do something. Right? And by the way, it's not only vary, and intensifiers like this also think about what is triggered by personal pronouns, by the way. The meaning of that is go and find an antecedent, if you can, right? Unless it's a pleonastic. So whatever, that's the meaning. Now, the example power tools shows one of the huge problems for English, as everybody knows, and that is processing of nominal compounds, because unlike big, whose meaning tells you what property it is referring to, which is size in its main meaning, right? Power can mean anything. It's not clear what property power and tool connects on. One of the big examples of this is this phrase IBM lecture. An IBM lecture can be a lecture at IBM, by IBM, about IBM, sponsored by IBM, and you can continue and continue. Right? This is a bona fide problem, and well, we need to specially discuss it, and yes, we have certain suggestions about it, but not at this point. Okay, so this is, I talked about expensive and so on, power tools, yes. So this is compositional ambiguity. And this is something that we need to deal with because, you see, we have been dealing with lexical or word sense ambiguity quite a lot. But with compositional ambiguity, I think a bit less. So we need to be dealing with this type of phenomenon too. Okay, one problem with this wonderful picture is that it breaks at every point. You see, first of all, I'm showing, you see, if you go through all of this and you still have more than one possible TMRs, you have a residual ambiguity. And this happens left and right. But not only, all the other things also happen. For instance, well, you know, it could be one TMR which would be great. By the way, unless it's a false positive, unless for some reason we made certain mistakes, but we remained with just one. But it's in many cases, for many different reasons, we can get less than one and more than one. And what we need to do is to have tools to deal with those situations somehow. Because you see, the premise here is that actually, well, I cannot prove this, but the hypothesis at this point, but the hypothesis is this, that no matter how good the set of static knowledge resources we have, there will still be cases, I would say multiple cases, in which the matching will not occur the way we predicted it would occur for the open text from the open source. Right. By the way, the reasons for this state of affairs could be multiple, because the preprocessor will stumble on a number of issues, or at least will not be able to produce a completely uniform, complete single answers for, well, the best answers for certain inputs. For instance, what about unknown words? This is a standard state of affairs. We can guess certain things about this, and we do, but it needs to be validated by people or by somebody to help. So syntactic analysis certainly can, first of all, everybody knows about attachment ambiguities, right? And these are rampant in almost in every sentence that has a prepositional phrase in English. Let's say you always have that. And that also everybody knows, oh, well, semantics can help resolve it. But where is the chicken, where is the egg? Here, you see, we are moving in this general direction of producing the semantic representation. And, well, I don't know how useful it is to go back and resolve the syntax after you guess semantics without the benefit of having the unambiguous syntactic analysis. But also there will be cases where, and they're rampant, where there will be, let's say, a zero syntactic analysis would be produced because people didn't write down the subcategorization patterns that indeed are appear in certain inputs. Well, you know, it's easy to say that well, the verb to sing in English is a transitive verb. You know, somebody, you know, Tweety sings a song, but it could be used obviously without a direct object. And if we don't mark the direct object as optional by mistake or by design, we lose if the process is not flexible, right? So all kinds of situations can occur, and we need to be able to do something about it. Okay, so this is, well, if it's less than one, it's an expected input in some sense, so we need to do recovery and repair. So if we use the above definitions of make, right, then the sentence "the gorilla makes tools" will not pass because it was human. Remember, the constraint was human on the agent. And in reality, what we have here is what's known as sortal incongruity. This was how Rich Thomason first described this type of situation. Also, an example like the baby ate a piece of paper. You see, because what you eat, right, you constrain to edible. But the piece of paper is not edible. But the sentence actually is meaningful. So you need to do something about this. And by the way, it could be also a case of metonymy, this the gorilla makes tools thing. If indeed the gorilla refers to a person, right? It's like the same example as the orange juice wants his chick, right? Famous examples. It's the same. So, by the way, a priori we don't know what it is. So we need to be prepared to go and try for both of these. That is, analyze both of these. Okay. So one way of dealing with this repair is to, oh, I don't have to. Well, I have so many slides, obviously, and yeah, let me just say it. So one way of dealing with repair is to go and change, modify the static knowledge sources, modify them both spot-like and also in principle. So what we did, for instance, we did variable selectional restrictions. In other words, our constraints in the systems that we're using are not constraints that are hard at one level, but have different what's known as facets. All right, so not to talk too long about this because I don't have the time. Instead of one value, we have a value of default constraint, the sem constraint, and the relaxable 2 constraint. So the sem is the level of abductive reasoning and the abductive violation that is general. If we have the default constraint for something, for instance, that the place where cooking occurs is a kitchen, right? That's about the level that we expect for it. That's the second one. And the relaxable 2 is used when we get the 0 output from the other constraints, right? What it is, well, I have examples here. And I have, okay, I cannot skip it. I could skip it only if it were. Okay, these are the definitions and descriptions of these facets that we use there. Okay, so the idea of multivalued selectional restrictions can be extended further, and it's something that we most probably need to do, to include static probabilistic values or even probabilistic values relative to a corpus. That is, what we could do there is a whole a continuum of values almost. And one difficulty in acquiring such knowledge is having to count probabilities of ontological concepts and not phrases of words in a text. So it's not one for one. So we need somehow to think about it. And this is something that I would like to be able to do. All of that I was talking about was about what to do. Oh, sorry. I thought it was like in the Japanese, you know, they play marches when your time is up. I was a recipient of one of these things, and that was great. You know, they smile, you know, the chair smiles. Enough of you. Great. Anyway, but selectional restrictions are not enough. This is what I'm trying to say. You know, individual constraints between the head of proposition and each of its arguments, typically available in static knowledge sources, are often not strong enough or too strong for effective selection of word senses, and there is no way in which you a priori could improve this so to the level that the input that the inputs that are coming are always expected. The real power of word sense selection lies in the ability to tighten or relax these constraints somehow dynamically, based not only on the static knowledge sources, but also on what has already been processed before in the text. And well, it says effective sense disambiguation should be held by the availability of rich knowledge resources elsewhere. This last point is a weak statement about the positive effects of having groups of concepts organized into scripts. That is, I was mentioning this earlier today, that the idea, the equivalent in the machine tractable form of having a subject label in LDOS, like geom or agr or chess, like rook in chess is this piece and rook in ornithology is that thing, right? So what we can do for that is organize typical large typical events and large typical objects into scripts, temporally organized for events, spatially organized for objects. We have been doing some of this. Of course, this whole angle of work ascends to the original work of Schenck in the early 70s, but with the difference that there were really very small toy analysis, and we have tried to redo the restaurant script. If you remember, that was the script that they were talking about, and we stopped after having produced 1,200 concepts to describe. It's so much when you really want to describe this area of the world in some detail. But unfortunately, this is something that's very helpful not only for disambiguation, because that's a side effect for it. It's also obviously one of the biggest tools for connecting the meanings of separate sentences into one coherent whole. And also you understand that they allow you to go and look specifically for lacunae about what is not said in the text, but what you would want to know about a particular event. That's that. And there are other purposes of using it. So there is that. But we also have, and I will not have the time to talk about this, but we also had experimented with two other ways of manipulating the combination of meanings. One of them was really do the dynamic tightening or relaxing of selectional restrictions based on the environment. That is, well, I have an example here that I want to go through. Maybe I should just do that. It's kind of a cute. Well, okay. This schematic will help. Imagine that we have a certain argument taken word, which is a part of a certain sentence, and we already established this meaning. Its meaning is a preposition add, and it has some kind of a case role with a constraint. This is the ontological subspace which this case role is constrained by. And there is another one which is constrained by this. And there is another word which is supposed, we know that its meaning should occupy this case role here that has three word senses. One of them does not conform at all, and two do conform, right? So it could be the case, look, that the word whose meaning occupies the this case role, right, appears on the scene, and when it does, when we know that instead of the big constraint for the case role, in practice, in this instance, the constraint is smaller, this whole thing can shrink. Do you see what I mean? The example that I can give, yeah, it's difficult.
Give an example.
Yeah. The example is this: if there is a, let's say, the English word to treat, and a lot of, in the sense of provide service, because there are other treats, like you can treat metal, but not that. So if you say, yeah, exactly. So if you say that, okay, if you say that it's a patient, then on the other side it will be some kind of a medical professional. You see? But if it's something else, if the host treats guests to something, it's different. And without one constraint, you cannot further constrain the other. So what we're talking about here is what I started calling lateral selectional restrictions. That is the ones that kind of, they don't exactly bypass the head, but are talking about the co-occurrence of certain, let's say, conceptual nominals together. And by the way, strangely enough, if we want to record this type of stuff, we end up with writing little scripts saying that, let's say that if there is a concept of treat, and we say that the agent could be, let's say, a medical professional. And then under that you can say, but if so, right, then the theme will be patient. Right, so you can list this one by one.
Is this very different from having multiple senses for treatment?
I think that it's not different. But the problem here is what is easier to acquire. You see, and also whether you see if we have a good level of inheritance there, then we indeed could inherit all the rest of the properties there too. Problem is though that, let's say this, in any practically acquired ontology and lexicon combination, this state of affairs cannot be guaranteed. It cannot be guaranteed that you will not need to do something like that. That is, that there will not come a new input where, according to your suggested methodology, you need to split the senses, right? And this could be, the regress point. So some kind of a, if possible, we should do it dynamically. Sometimes you can, sometimes you cannot. In that case, if this shrinking does not occur, right, then the best you can do is to go to the lowest common ancestor of the two candidates and say that this is how it should be constrained, and that means that we lose the precision, not in that sense, but the precision of the semantic representation, but we at least don't violate it. So the weakest situation there would be, it could be anything here, right? So patients are treated by anybody who can be an agent, that is, let's say, human in an organization. Okay, I'm sorry, it's kind of not detailed enough. Okay, I suppose, okay, I'll just mention one more situation for the analysis, and I think I'll have to stop, and this is the following. Considering that we have an ontology, which is not only a subsumption hierarchy, because the elements there are interconnected on 350 different properties. That ontology in itself is a search space, potentially. So if we manage, and we did an exercise on this already, if we manage to somehow learn the relative cost of traversing different types of links, if we use the metaphor of a network, or rather different properties, presence of different type of properties, then what we can do, instead of relying, or in addition to relying on static recorded selectional restrictions, is simply to calculate the distances between the target, that is what is the constraint on the receiving word, and any number of meanings of potential fillers for that slot, and to choose the one that is shortest, right? We have built a program like that. It was the dissertation of one of my graduate students that is called OntoSearch, and we trained this on 40 different types of relations, and used simulated annealing with in the usual standard sense to train it. I'm sure that we can do much better on that exercise that we did once, and we would want to continue doing that. So to summarize this little introduction of the different types of analysis, and I was talking only about the production of semantic dependency, because there are other parts of analysis that we call additional microtheories, and those are, well, I'll show you one slide about this. I will not show you a slide about this. Right, but what I'm trying to say is that even for this component, there are different types of processing that we are trying to perform, and there is no doubt that we need to improve this by connecting this like more tightly in a single approach. Moreover, in any we can treat our static knowledge sources as simply resources on which to calculate any number of measures that could be calculated, because because they are there. That's why people are using WordNet. And this is where we want to go. I suppose I'll stop here. What I want to only say is that there are various other pieces of work and past and present in here, including a lot that we have done on acquisition and the tools, and including also those microtheories that I will not talk about. For instance, work on reference, work on modalities, work on aspect and such. So I hope maybe sometime in the future I or some of my colleagues could come and give some specific talks that will be less amorphous than this one, and we could talk about things in technical detail. Sorry. Yeah.
Questions?
Have you thought of mapping WordNet senses to nodes in your ontology?
No, I haven't thought about this because, if from the point of view of coverage, it could be a good exercise simply because there are sense sets to increase the size of the lexicon as we already have it. One problem that I have with, among many others, with WordNet is simply the pure size of lexical entry, the number of senses in each entry. You see, we obviously tend to like to bunch the senses, because providing disambiguating power for 12 senses of some word is more difficult than providing disambiguating power for 3. And so I have a little bit of a problem there. Like you have in LDOS you have 11 senses of bank, and I want 2. Yeah. So not that this is right or wrong. It's simply that it's not necessarily convenient. Yeah.
So I was intrigued by your comment that to encode the restaurant script it took you 12,000 axioms and counting.
Well, it's not axioms. We don't call them axioms.
I'm sorry.
We're not calling them axioms. It's concepts.
Concepts, all right.
Yeah.
So I'm curious about why that is. I can think of a number of possible reasons. One is that you're trying
Excuse
to...
me, is it the restaurant script, is that something?
Something it's Shang.
Yeah.
It's John goes into the restaurant. I mean, you do I don't know the story exactly.
Well, it doesn't matter. The story is
I just wanted to know it's a standard thing which everybody refers to.
Right, but not everybody here necessarily knows it. So.
I don't think anybody knows it, but go ahead.
The idea is John goes into a restaurant, he orders a hamburger, it's not cooked enough, he leaves. And then, you can ask questions like, did John pay for the hamburger?
And also the fact that it says he went into a restaurant, the waiter was late in coming. Why that?
Yes.
Okay.
Right. So I mean, you're filling in lots of roles implicitly because you have some background.
Environment, utensils, types of events, types of events. That is, well, we call them events. That cooking involves. You do this and dicing and tossing and sauteing and all that type of stuff.
So this leads to my question.
Yeah.
did it take you 12,000 axioms, 12,000 concepts, I'm sorry, because you were trying to encode a complete theory of economic transactions, cooking, and service? I mean, did you have sautéing in the model? If you did, I understand why there were so many axioms.
Yeah, that's
Yeah, all right. So you might have been able to get away with fewer
I'm
axioms for a
sure.
shallow model.
I'm absolutely sure that we could, but you see, at the time we didn't think about this way, right? We were kind of, this was for us a way of enhancing the size of our knowledge resources.
Would it have helped to have also a more expressive, a more expressive notation for concepts, including schemas? So you talk, for example, about many senses of bank. You only want two. Presumably, that's because you can derive bank as bank as building from bank as institution or something like that.
In part.
And so you don't need both.
In part. But you see, this is good that you asked. You see, my feeling is that it's not so much a matter of the notation as the expressive power of the notation together with the alphabet, together with the meta-lexicon. You see, so because for us the notation.
Well, Shank himself tried to get away from that, right?
Well, but
that's
you had games.
He tried to reduce the number of
Yeah,
verbs
no, we
tremendously,
don't do
right?
that.
Yeah, okay.
No. It's that is a game. What we follow the precept that Pat Hayes said. You know, the only thing that we can do is this famous relation. You know, the number of elements in your meta language and the number of elements in the language that it describes should be as low as possible. But other than that, because it's not a game of how you can combine 12. Until now, there are people who are playing games saying that every meaning in the language can be combined from 20 or 15 or 36 primitive senses. It's not interesting.
The only reason that it's interesting is it tells you how much of the difficulty is in the lexicon and how much is in the concepts.
Yeah, but
in other words, if you make a firm distinction between the two, then you might be able to see that the concepts are relatively small. We just have a lot of words.
Well, fair enough. It's the combination, but then you have to have rules of combining them in a certain specified way. But you see, the content of the semantic zone of the lexicon is the meaning. It simply it uses the meta language provided in the ontology and the TMR to express the meaning of this lexical unit. And there are many other meanings in the world that are not directly expressible by, correspond to a lexical unit. But no,
all those things you wish you had a word for.
The tops of your feet. Remember that? Yeah, you don't have, but that's fair enough. By the way, that's another thing that we it's a point. You know, every language can express everything, and we are somehow fixated on the level of single words. But so you use a phrase to explain something. Fair enough. Yeah, right. But no, there was no ulterior reason in our doing this to that level of detail. We simply wanted to see how much it would take to really do something that would kind of expect to process more text. By the way, stop. Yeah.
One more question, if there is one.
Sorry. I'm wondering if you are thinking about marking up corpora with some of these concepts, such that one might train with.
Yeah, but yes. In other words, what you're talking about is running the analyzer on large texts and retaining the TMRs. Right. We have started doing this, even though the going is still rough, because we want the quality to be high. That's, you see, what we are trying to do is not to say it's 70%, but to push it to 100 if we can. It's not 100. It's less. By definition, it cannot be. It's like alcohol in the air. You see, it couldn't be 100 degrees. It's 96 because it, it's whatever. It's sucks it in. The idea of the task of producing a fact database off of TMRs exactly involves that. So eventually, we hope we will get more and more. Right now, we have we stored something like, I would say maybe 10,000 words of text only.
Okay.